Hello class, let's go ahead and look at lesson 2 in geometry, and we're talking about line segments. Now a line segment is a part of a line consisting of two endpoints and all points between them. So a line segment ends with points. That means it actually has a measurement because a line goes on infinite. So this line has endpoints of A and B. Therefore, it is a line segment. How you would write that is AB, and you put a line with no arrows on top of it. And that's how you classify a line segment. Now right here, we have two line segments A and B with a value of 5, and C and D with a value of 5. Now, like I said, because it is a segment, it can actually have a measurement. Now, since A and B and C and D have the same length measure, what they can be called is congruent. This is the symbol for congruent. 5 equals 5. But when you are referring to lines, AB is congruent to CD. So the difference between equals and congruent is equals is referring to numbers. Congruent is going to be referring to measurements of shapes, lines, different things like that. So we could say AB is congruent to CD because they have the same measure of 5. And they are congruent segments. They have the same length, size, and shape. How we could label these, just real quick, is say we didn't know the measurement. If they had a little tick mark, we could say that AB and CD are congruent because the tick mark refers to congruence. It says that they are the same length. Moving on to a couple of definitions here, or properties. You will have to know these later when we do proofs. So, jot these down and memorize. They're not hard at all, but you just have to make sure you know which one is which. The first property is reflexive, property of congruence, and that is just saying AB is congruent to AB. So if you have two, if you have two lines, okay, AB is congruent to itself. Now, if it ever said, say it looked like this, 5 is equal to 5. That's reflexive property, but that would actually be of equality. This would actually be reflexive property of equality because it has an equal sign. So just so you know, just in the future, equality and congruence, they're slightly different, but the property remains the same. You also have the symmetric property of congruence. Symmetric property is if AB is congruent to CD, like so. If AB is congruent to CD, then CD is congruent to AB. It's just reversing the order, flipping it. That's all that the symmetric property of congruence is. Don't really need to spend much time on that. And then transitive property, always a fun one. Transitive property is if AB is congruent to CD. We know these are congruent. And then CD is congruent to EF. We know these are congruent. Then we would automatically know that AB is congruent to EF. And so that's just the transitive property of congruence, is all that is. And those are just 3 properties. Just make sure you know those, jot those down, remember those for when we might need them in the future. It's just introducing them early on. Next, we're just going to go over postulate 1, just a couple definitions before we get to some basic math stuff in this lesson. Postulate 1, first of all, a postulate, let me define what a postulate is. A postulate is a statement that is just accepted to be true without a proof. All right, we just accept these statements to be true. And postulate 1, scoop this up, says that the points on a line can be paired in a one-to-one correspondence with real numbers such that any two given points can have coordinates 0 and 1. The distance between 2 points is the absolute value of the difference of their coordinates. That's a lot of words to define what we're about to do. So let's simplify it a little bit and try to get rid of all this clutter. Say you have line segment AB. I've got a number line here. A lies on the number 2, B lies on the number 4. All this postulate is saying is that you could find the distance between A and B simply doing the difference of their absolute values. So absolute value is you have the line on the outside. It's going to always be a positive number. And the difference stands for subtraction. So difference of point A to point B minus 4, absolute value. So you solve inside, think of the absolute value like parentheses. 2 minus 4 is negative 2. Well, absolute value is simply how far is the number away from 0. So if you have a line, and this is negative 2, absolute value is saying how far is negative 2 from the number 0. Well, it's not a distance of negative 2. It's a distance of 2 to the number 0. So therefore, this simply means 2, and you've probably done that before. So 2 is the distance from point A to point B. Now, obviously, you can count, but when we get into bigger numbers, you're going to want to do the difference. But you could also do point B minus point A. I'll show you real quick. Point B is 4. Point A is 2. So the absolute value of 4 minus 2 is simply 2. It's just showing you that it's the same thing. But that is some definitions in lesson 2. Next, let's move to some examples. Let's continue in lesson 2. I'm looking at example 2. It just says find each distance. So we need to find the distance from A to B. Now, yes, you could count 1, 2, 3. Distance is 3. But you just remember you can always do the absolute value. I'm going to go ahead and say this is 3 just for time's sake. But you can always do the absolute value of 6 minus 3. That would be 3. Or 3 minus 6. Remember, absolute value is always positive. So 3 minus 6, negative 3, be a positive 3. Distance from B to C. This is a little bit longer. You could count, but I could just do 3 from B minus, C is negative 5, so you actually have to write negative 5. Oops. You need to still write negative 5. So you have 3 minus negative 5. It's always the difference. Don't let the negative make you put an addition sign there. But 3 minus negative 5, 2 negatives is a positive. So therefore, that's 3 plus 5. Your distance would be 8. If you did negative 5 minus 3, that's negative 8, absolute value, 8. CD, negative 5 minus negative 1, absolute value, negative 5, negative 1. Negative 5, 2 negatives make a positive. Negative 5 plus 1 is absolute value of negative 4, so therefore your answer is 4. You can't have a negative distance. That's not a thing. There's not a negative on a ruler. You always have a positive distance. And then AC, long one, 6 is A, that's point A. C is negative 5, so minus negative 5, absolute value. 2 negatives make a positive. 6 plus 5, 11, is your distance from A to C. And that's how you do distance. That's all you do there. Now looking at postulate 2, segment addition postulate, if B, and well, let's do this. If B is between A and C, B is between A and C, then AB plus BC, AB plus BC must equal the total AC. Very self-explanatory. So let's break that down into some examples. Example A says point S is on line RT and between R and T. So that would look like this. R, T, S is somewhere between it. And then it says RS is 12. So right here is 12. And then it says RT, the total, let's write this here, is 31. So how would we find ST? Well, you could use your addition postulate and say 12 plus ST equals 31. And then you solve it algebraically and you would subtract the 12 and get 19 for your answer. 19 would be the answer. Most of y'all could probably see that you would subtract the 12 from 31 to find ST, and you can totally skip steps however you want to do it. Just get the right answer. Awesome. So 19 would be your answer for A. B, it gives you this line here. It gives you the distance from A to B, 2x minus 7, and the distance from B to C as 3x plus 9. And then it says to find AC. Find AC. Well, to find the total, we add the two little lines, A, B, and BC. And so we add AB, 2x minus 7. I'm going to put that in a quantity format with parentheses, plus the quantity of 3x plus 9. Move this back so you can see. Plus 3x plus 9. And since there's nothing in front of the parentheses and it's all positives, I can go ahead and eliminate the parentheses to make it easy math. I would just add like terms. 2x and 3x is 5x. Negative 7 and 9 together is 2. So I know it's weird, but the value of line AC simplified is 5x plus 2. That is actually your answer. It cannot be solved any further, so that is simplified. So that's postulate 2, the segment addition postulate. One more part in lesson 2, midpoints. And midpoint is very simple. If you have line AB, and you have these two tick marks, so here's AM, and it's saying AM is congruent to MB. Well, if these two lines, that means this whole line is basically cut into two congruent halves. So therefore, this point in the middle is called our midpoint. So if this was 10, if MB was 10, we would automatically know that AM is 10 because M is halfway, and we would know that the total is 20. So that's midpoint. And then example 4, yeah, it does the whole word problem, but this is what it would look like. It says this chick hiking up the mountain, X to Z is the location. How far is it from X to Y? If the length of the, Y is the midpoint, and the length of the mountain is like 2.5, whatever, 2.5 miles. Whoa. No thank you. 2.5 miles is the total distance, and it wants to find the distance from X to Y, and it says it's a midpoint. Well, most of you probably guessed, all you would have to do is divide 2.5 by 2, and that would be 1.25. So the distance of XY is 1.25. Notice if it was 1.25 for that one, it would be 1.25 for that one. That would actually add up to be 2.5, and that is all that is lesson 2. So the math is pretty easy. Just add some definitions here and there.